Hello, everybody.
How's it going?
Hey, Benjamin.
Hey, I'm out and about right now, so I'm going to be doing it from participating via my mobile device.
Sorry, one sec. My headphones apparently are not connected. One sec.
Are they working now?
All right, try talking again, Benjamin, real quick.
Can you hear me now?
Yeah, perfect. There we are.
Okay. Yeah, sorry, I was just saying that I'm out and about right now, so I'm going to be listening in on my phone. So I won't be able to record it today. So if you, I mean, it looks like you are recording it all right now,
Yeah.
but then you can send it to me later.
Sounds good.
So if I mute myself and turn the screen off, I'll just be listening in.
That's fine. We'll just give the other guys a couple minutes to show up. Guys and gals, I should say. How are you, Ashley?
I'm doing pretty good. How are you?
How's your foot?
No legs, but I can walk around.
That's good. I'm glad.
How's the baby?
He's doing awesome.
Yeah?
He's now only waking up twice a night. So we're actually getting like decent sleep. But I've gotten really. Go ahead,
What did you
Benjamin.
name your baby?
Logan,
Logan?
which
That's awesome.
we totally named him after Logan, who works in the shop. I'm just kidding. No,
That's
to be
hilarious.
honest though, we kind of did, because one day, if you guys ever have kids, you'll, especially if you have a boy, you'll realize there's a lot of guys in the world whose names are completely ruined just because they're weird. Like,
Yep.
could never name a kid Grant, could never name a kid Greg. Like, because there's just too many weird Grants and Gregs I've ever known. And Logan, we were talking about it, we were like, yeah, there's no weird people associated with Logan. We can claim that one. So
That's awesome. So
in a way,
did you like
we
have a
did.
specific an ancestor or somebody, or did you
Nope.
like literally name him after Logan?
We kind of
'cause you like
forgot
the
to
name?
come. Yeah, we just liked the name. We kind of forgot about it until because he came a week early, so we weren't really expecting him yet, which we should have been. But and we were just like, oh shoot, we forgot to come up with a name. And like there he is screaming like, what's his name? We go, Logan. So it just kind of popped out and it stuck. So
That's awesome.
better than
It's better
naming
than
him
my
like,
parents. Yeah.
oh, your
It
parents?
took them like 2 weeks to name one of my younger siblings, and like we were all just, what do we call it?
That's hilarious. Cool. Well, let me pull up. I'll silence you guys so you don't hear my.
How are you doing, Benjamin?
I'm doing good.
Just chilling?
Just waiting. Yeah, I mean, I'm here at Jiffy Lube getting the car lubed, so I've been procrastinating. I should have done this like a couple weeks ago, but finally
No better
decided to do
time
it.
to do it.
I know. I want to get back into the shop, but my dad's like, not with your siblings who work at the assisted living center.
Oh,
Like,
yeah.
but
Yeah.
hopefully one of these days I can get the green light.
Yeah. I haven't been to the shop in like since March.
Yeah, I haven't, when it ended, no, I'm in the shower. Sorry.
You got a restroom out here if you need it. There's gonna be some water.
Who else
left,
joined?
and it's gonna kick back, relax, get your Thank you.
The prototyping lab, so I guess it's the people in the shop.
And the Anna's name?
The Astro?
Yeah.
Okay, I'm gonna mute myself right now.
Okie dokie, we got a couple people. I guess we'll get going. How's it going, Lizzie? It's fun. It's always funny when someone, especially a girl, is carrying around a phone because your hair, like your head doesn't change position, but your hair just goes whoosh, 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 whoosh. It's really funny. Okay. Okay, cool. Austin, the real Luke, Dallin, and Turner. Okay, awesome. Oh, and there's Logan. Mr. had a brush with coronavirus but didn't get it. Good job, Logan. Okay, guys. Well, I guess we'll get started. Oh, you guys do have a camera now. Okay. I guess first thing is, how many of you guys had a chance to do any of the like practice assignments we gave out like 2 weeks ago? I think the 2D adaptive practice, and then I think just a couple days ago I put up that bulkhead. Did any of you get a chance to do the 2D adaptive stuff? Okay, cool. Well, if you did, you'll get a lot from this. If not, go and do it. It'll be good. And then we've got another one today. So today we'll be talking about bores, circulars, and engraving toolpaths, which those ones are a little bit different in Mastercam versus Fusion. So hopefully we'll be able to find some good differences there. Okay, I'm gonna share my screen. And okay, so first things first, let's do this. Put that away for now. Okay, so with the 2D contour practice, oh, that's what I didn't pull up. I'm gonna open up that 2D contour practice that you guys were working on. Just give me a second. Where is it? Okay, so in that 2D practice, you guys who did it, you went through a bunch of different things. Basically, you took this guy, and on a bunch of these different pockets, you used different tools and used different parameters to mill out a bunch of these tool paths. So one of the big things with the 2D adaptive that I hope you guys got out of this practice assignment was the difference in selections. So when we come into here, actually, let me just make a brand new one. Oh, dang it. See, the window where I see your faces perfectly hides where that window pops up. Okay, so when I come in to create a 2D adaptive and I have some tool and yada yada, when I come in to select my geometry, we talked about the difference between selecting a face versus selecting a contour. And one of the big things in there, and something that I've been since learning, is when you select a face, Fusion has a little bit more information to work with. It can detect that there's a face that drops down over here and faces that come up. Therefore, it's able to guess that what you're looking for is approaching and using this as an air region where you can approach from the outside and not hit anything. Mastercam doesn't make any assumptions like that, which is powerful, and yet sometimes you just wish it would. The other way I have you guys select this in that practice assignment was to go in and select this chain, just that guy, and verify which side this arrow is on. So you'll notice when the arrow is on this side, we'll mill from this edge of the pocket. And once again, Fusion uses a little bit of background information to figure out what exactly you're wanting to do. Versus when we click that arrow, we get off to the other side. In the next practice assignments you guys are gonna do, you'll have to do some other weird stuff too. Sorry, one sec. Excuse me. Can you guys hear me now? Sorry, I lost my video. Yep, great. So you notice when I flip that arrow, now Fusion is using what it knows about my stock and what it knows about that contour and the side I told it So now it's saying, oh, okay, you want me to mill away all of this stuff and leave these intact, which is not what we want to do. But if we just add a contour, that's the best Fusion's going to be able to figure out. So what you guys are going to end up with is you can end up with a situation where you've got something along these lines. So let's say I want to select the contour that borders this face. I select that contour, but that's not entirely what I do. So if you remember in Fusion, you click on that again. You select whether you want a closed or an open contour, and then in this case, closed, and Fusion guesses. We accept it, and we move on. I check the arrow and make sure the arrow is, what the heck, is highlighting this internal section here. What this allows me to do is sometimes there'll be geometry on a face that you don't want Fusion to know about. Geometry that's below the plane you're milling at, you don't want Fusion to care in some scenarios. You'll see this when you come in to the practice assignment I've got for you guys this week. And we'll talk a little bit more about it then. But that was just a brief review of how to do the contour versus the face. Any questions on that one before we go on to talking about optimal load? Awesome. So once again, reviewing from that practice assignment, the optimal load in your practice parameter is like your step over in Mastercam. And remember, we get at the percentages and stuff by this edit expression button. And this takes us into this math window where we can use the tool diameter and multiply by some percentage to set our step over. In that practice assignment, you guys played with that and found that different tool percentage of step over stuff makes crazy things happen. You will also have played with minimum cutting radius parameter, which I'll bump up to 0.1 inches right now. And we'll briefly review what those two do. So the step over now is using more of the diameter of my tool to cut. And then on these corners, the radius that it's putting on that corner is now larger. And you got that. Okay, another thing, yeah, go for it.
Really quick, is there a good rule of thumb for like the percentage you want to use for the optimal load?
Yeah, so that is a great question. And feel free, thanks Ashley for asking that. Feel free guys to ask me feeds and speeds questions as much as you want to. It's really hard when you guys can't get at the machines to really get a baseline for these things. But I will tell you with the optimal load, what this tends to be in a milling scenario is it really depends on a bunch of factors, but generally you'll go 10% to like 15%-ish if you're working in aluminum. In mild steel or stainless, you'll use different numbers, and that depends on your step down, as well as how deep your tool is cutting, what material you're cutting, and the step over all kind of match. And let me show you something else. Basically, the rule of thumb there is you want to keep, for a given like material and situation combo, I'm just gonna, oh no, it's your practice assignment. Don't look. So basically, Ashley, imagine here's my stock, here's my tool. Basically, these two are gonna overlap some amount as you're cutting. And you see if I bring it deeper, that rectangle gets bigger. If I bring it in, that rectangle gets bigger. Basically what you're doing is you're keeping this overlap area to be about the same for a given speed and a given material. So if I were stepping down, let's erase those. Oh, phooey. So if I were going down really deep, I'd use less of a step over. I'd have my tool kind of make a really thin, tall rectangle. If I were going really shallow, I can step over a little bit more to keep that area the same. Does that make sense, Ashley? Okay. In the router world, we tend to do a large step over, but a shallow step down. And we do the opposite in VMC world, we tend to do a large step down with a very small step over so that we're using the maximum flute lengths. For reference, Ashley, when I'm on the VF4 or DM1, typically I'm running at 10 to 15%. When I'm on a router, I generally do like 45, or in some materials I'll do 75% step over. One other note about this is 50% is a very bad number, and you never want to use that for any reason. You get all sorts of tool chatter issues specifically at that. 45, great. 55, great. But 50 is an absolute no-no. So there's more on that when you look into chatter and stuff, but just so you guys are aware. Yeah, say I was making this out of wood, I'd do probably 40% step over and then a really small step down. Awesome. Minimum cutting radius. We can also edit that expression and do a tool diameter. And you see, as I start typing, it shows me the stuff I can do. So I'm going to find my tool diameter, hit enter, and multiply that by, I don't know, we'll say Mastercam, the minimum it lets you go is 2.5% of your tool diameter, and it defaults to 10% of your tool diameter. Once again, that's a chatter thing. 2.5%, you'll get more chatter than 10%. But you also can't hit those corners as well. And I'll just show you guys too how we simulate. So some Fusion tips real quick. If I select my setup and hit simulate, it's gonna go simulate all of the operations in that setup. But I can come in and just control click those two and simulate those, and it'll bring it in. So you'll notice when you guys come in here, usually what it'll do is it'll have only the tool and tool path set up. So if I start running this, all I'm seeing is my tool run through. I'm not actually seeing anything cut. I usually disable toolpath and show stock, and then that'll actually display what you're machining. Some other fun things in here. If you could go to next move, it just moves one step forward in the G code. But if you hit go to next operation, it'll simulate all the stock and then jump to the next operation in the list. So you'll see in here, this is what this guy's doing. And I'll show you the effect of that minimum corner radius. And I'm just gonna go to next operation so I can show you. Oh, I didn't realize. So you'll see the edge of my geometry and the edge that I milled have some offset. Who can tell me what that means? Anyone have a stab at it? If I had selected this contour down here and my tool didn't quite get there, it means I'm leaving stock on walls. So that looks like I probably have 20 thou stock on walls there, so I'm not quite reaching where I need to. Here you can see the effects of that corner radius. Even though my tool's diameter was not quite as large as that, it's making sure the tool never fully stops and then changes direction. So instead of moving like this and then changing, it'll round that corner to make sure this tool doesn't stop and chatter. If we were on the machines, you guys would be able to see a big difference in the surface finish of those two parts. Okay, any questions about that step over or minimum tool radius? Okay, sweet. The next thing to chat about is Fusion's rest machining options. For those of you who are familiar with Mastercam, Fusion's rest machining for 2D adaptive at least is really weird. In Mastercam, what it'll do is it'll simulate the previous tool paths and then say, okay, this is the stock that's left. That's the only stuff I need to machine. In a 2D operation in Fusion though, the only input you have to rest machining is a previous tool diameter and corner radius. Corner radius being what you get on like a bullnose end mill, where it's like a this shape as opposed to completely square end, has the rounded corners. In this case, you could do a ball end mill as well. Let's say I roughed with a 1/2 inch ball end mill. I'd have a quarter radius of a 1/4 inch, which roughing with a ball end mill is dumb and you should never do it. But you'll rough with a 1/2 inch bull nose very frequently because we have those loaded in the machine now. So I can tell this toolpath, hey, I went through with a 1/2 inch bull nose. I want you to clean up everything I wasn't able to get with that tool. It's a little primitive method of stock, but what you're seeing it do here is saying, okay, he couldn't get into this pocket with a 1/2 inch end mill, so I'm gonna bust out that. Because it was a bull nose, he couldn't get at these bottom corners, so I'm gonna rough those out. And then because he had a larger diameter tool, his corner radius was larger, so I'm gonna come mill this out here. And if you see on, oh, wrong toolpath. For those who've done the practice assignment, you'll have done that firsthand and seen what it does. Okay. Any questions on rest machining as it stands in a 2D operation? Okay, sweet. When we get to 3D operations, you'll see that 3D operations do simulate stock and do it just like Mastercam does, which is really useful. That being said, you can use a 3D adaptive clearing in almost any situation you'd use a 2D adaptive clearing, but the selection method is different. And we'll talk about that when we start getting to 3D operations. Okay, awesome guys. I think that covers that. I'll challenge those of you who haven't done the practice assignment to go through, and I handed you an F3D file, so you get this full file with some stuff in here already. In this roughing out some stuff folder, you have this adaptive. This is a 3D adaptive that I created to just rough out all the material. So this is with 1 inch end mill, and it comes in and just not good parameters for machining, but it roughs it out so that you can actually see the pockets. The challenge is, and still stands, to replace that with a 2D adaptive clearing and do all the selections you need to get it done. Briefly, I'll just show you one tip on that. So if I create a new adaptive, it comes in here. When I finish, I can drag that up into that folder and it'll go first. But let me show you something that happens when you select multiple things. So if I select this and this and this, Fusion will actually calculate the right depths for each of those things in the adaptive toolpath. So you can select multiple things in one 2D adaptive, and you'll notice it generate toolpaths for each of those pockets individually. And here we see one of the drawbacks of face selection is even though these features are below, Fusion assumes that there's no stock above as well because I selected that face. This is a situation where you'd want to use a contour to select. But as you see it generate each of those toolpaths, you can select multiple things in one. Okay. So that challenge still remains. If you haven't done the 2D contour practice, please do it. It's 2D adaptives, I mean, are one of the most used toolpaths you'll ever use in Fusion 360 when people are coming on the router. They're also one of the toolpaths with the most parameters that are easy to mess up. So when people come through on the Shop Saber and they're having programs that we need to check over, adaptive toolpaths are going to be one of the ones that we need to check every single time. And we need to go through it in depth and in detail to make sure they didn't do stupid things. Like if they were planning on roughing out this entire pocket and they only rough this out, you get problems. I'll show you one situation where that comes into play next time after you guys have done the practice for bores, circulars, and graves. Okay, I think we're going to move on beyond 2D adaptives. What questions do you guys have about 2D adaptives, about feeds and speeds for them, about anything on that front?
Really quick, can we go over the stock contours from the last problem?
Yeah, totally. Let me pull that up and remind myself what it is. Stock contours option. Okay. Yeah, I remember that one now. That one is for machining this island. So I'm gonna edit this toolpath and I'm going to delete that, delete that. Ah, it didn't work. Okay, okay. So I select this face, and you're asking about the stock contours option. So what the stock contours option does is it tells your machine, by default, when this is unchecked, this is what your machine is assuming. So that yellow line is saying, okay, everything contained within this yellow line is stock. Assume that my stock comes up to this and figure it out from there. But Fusion uses some other information to that. So if I click that stock contours and I click OK, you'll notice my toolpath is going to generate all the way from the outside. I've told it, I selected this face, but my stock goes all the way out to here. You need to get rid of everything. Which, in the case of having roughed out all that stuff already, we don't need to. So, Fusion's default unchecked, I said earlier, was this yellow line, but I'm wrong. Unchecked, it goes based on your selection. So in this case, this is what it's assuming. So you see how that contour on the outside, that red one right now, that guy's slightly yellowed. I've told it that is the edge of my stock and only compute stuff within that box. This is what it does by default when you don't have stock contours selected. So I've told it, ignore everything outside this box. I've already machined it, don't worry about it. I will make sure you don't hit anything. And that's by selecting that specific spot. If I unselect it, then Fusion says, okay, I'm gonna try to figure it out based on your face selection. And since I clicked that face and it sees all of the walls around it are going down, it's gonna make that assumption that I've already roughed everything out. Now that can be a bad thing too. Let's say I haven't roughed out everything, and this is actually the first operation I'm gonna do before this roughing out some stuff. So I come in here and I say, okay, great. I just wanna do that pocket first. When I come in and simulate it, I'm gonna have a crash. So that red line means I had a collision with stock. And if we go back to the beginning and slow it down, you see it rapid moves and then collides with the stock right there. So it is moving rapidly through the stock and not at a cutting feed rate. So it would break our tool. You also see it's cutting a full slot width when it's expecting to only cut 10 to 15% of a step over, if that makes sense. So that is one of the parameters that makes a 2D adaptive very versatile, but also really easy to break. In this case, my stock contours, I'd want to use this whole thing as my stock contours. And that's the default selection when I check it. Then I come in and I generate it. And it's gonna take a hot minute because my computer's slow. But if we were to go through and simulate this, we'd see it successfully cuts the stock and never crashes and doesn't do anything weird. Okay, it does do something weird. So because we told it the stock was there, but this is the only stuff it cared about, it's gonna cut off these pegs. So there you have it, Ashley. Any other questions about that stock contours option? Sweet. Okay. Thanks, guys. 2D adaptive is great. Okay, did any of you get a chance to play with the bulkhead and try using 2D contours and adaptive operations to machine this out as if a student had brought it? Okay, sweet, that's okay. This is a fun exercise. I'd actually recommend doing it after the lesson we have today, because you're gonna want to use some bores instead of 2D contours. So let me walk you through how I did this. So I made a setup, Z being up, of course, X this way, Y that way. This is actually a piece I machined on my router at home. I did it out of aluminum, and it was chattery as all get out, and it was terrible, but I learned. So I start off, let me just simulate this for you guys. So this is all with 2D contours and adaptive operations. I'll show you in a minute how I could have saved myself some time using what's called a bore operation, but this is a totally valid way to do it. I started out by slotting out, which this was a bad idea, full slot width, cutting out a circle, because I didn't want to have to rough out all of the material around it. That was a bad idea. Then I came in and I did an adaptive toolpath, a 2D adaptive, to rough out this kind of shelf here. And I apologize for the outrageously slow simulation. I had to tickle it to death on my router. You see it come in with that 2D adaptive with multiple depths, it gets that. And then it comes in and does a 2D ramped contour. Then it comes in and roughs out this middle part. Oh, geez. Roughs out that middle part. And then comes and does, where are you? Christmas. Why can't I find you? I think this is it. Nope, that's in the middle. Okay. In just a second, what it's going to do is it's going to use that 2D contouring operation. And remember how we talked about being able to do a ramp where it ramps continuously around the outside or inside of a contour? That's how I did these holes. Instead of throwing on a drill bit or instead of plunging straight down, I had it kind of spiral down. In Mastercam, that's called a helix bore. And we'll use it on the router probably even more often than we use it in Mastercam, because we'll only have 1 or 2 drill bits to set up on the router and no spot drill. So it's a pain in the rear to try to use the router for drilling operations. But we can get the same geometry just with an end mill and a bore toolpath. In this case, I used a 2D contour, and let me show you how that contour was set up. In order to do that, I had to come in, I had to select my tool, select my geometry, which was a specific edge on the bottom. I had to come in and disable a bunch of things. So I had to set my heights right. I had to set my passes so that it was not doing multiple depths. I had to enable stock to leave in stuff and smoothing. Then I had to come in, check my ramp, figure out a ramp angle and a maximum ramp step down, which are 2 parameters that fight each other. And in other words, I had to do a lot of button clicking to make this work. If I had been smarter, however, I would have come in, gone into my 2D operations, and clicked bore. Bore and circular are 2 toolpaths that are really similar. I'm basically only going to show you the bore today because bore and cylinder have essentially the same parameters. But in the practice, you'll take it. Now you'll see with bore, I'm not selecting edges, I'm selecting faces. So I want to bore out that face. And you see it already previews what my toolpath is going to look like. Because it's such a simple operation, it can do that. All I have to do then is say, okay, I want to do that. I'm going to select all of the holes with the same diameter based on my 1 selection. My heights, it's going to take from that geometry, so I don't have to care if I've got it set up right. All I have to change is my pitch, which is the step down on each of these things. Or I can tell it, I want to use a ramp angle instead. Instead of the 2D contour where we have to have those 2 fight each other and it will automatically determine which one it uses, this one we get to be explicit and tell it exactly what we want to do. In this case, ramp angle versus pitch, In this case, I'd probably actually want to use a ramp angle. So basically, let me explain the difference between the two. Pitch, I tell it how far down I want it to go on each step. This is useful if you have a really long contour that you're going around, and say, okay, I want to have it go down 1/8 of an inch every time, and then you know that tip is only down 1/8 of an inch ever. Ramp angle is useful in really tight spaces like this. If I were using a pitch of, let's say, let's go 80 thou. If I were using a pitch of 80 thou, looking at that tool path, I'm primarily plunging. I'm not primarily side cutting. Instead, I'd come in and use a ramp angle and say, okay, a 2-degree ramp angle with a 1/4 inch ML is not going to give me much chatter, so I'm going to do that. Then the glory of this toolpath is I'm done. You click 3 buttons and you can get holes where you need them to. You can select all holes that have the same diameter, and you can do it real quick. In this case, then I can come in and simulate this, and okay, it's gonna have a little of a crash because I didn't simulate the other stuff. But you see, it's a lot easier to work with. When we talk about drilling operations, you'll see bores and drilling operations go hand in hand. Okay, what questions do you guys have about bore operations? Okay, sweet. Bore operations are probably going to be, I'd say, on the hierarchy of stuff we're going to use on the router. Primarily, we're probably going to use 2D contours. Secondarily, bore operations. And tertiary, we'll probably use 2D adaptives. Those are probably the only 3 toolpaths that the majority of students on the CNC router are going to use. And those are kind of your 3 bread and butter operations for anything on the router. 3D operations on a router are a lot less common because you're working with plate stock as opposed to like square or bar stock. Okay, great. I'll just show you real quick. The circular is much the same thing with the same tool and same face selection. I can also select the same diameter. I get the same controls there, same heights. But instead of going down gradually, the circular operation takes steps down. So it'll actually plunge, cut, plunge, cut, plunge, cut. You guys will play with that a little bit in your post practice, and I hope you'll learn something good. Okay. Any questions on bores and circular operations?
So when would you want to use which one?
Oh, totally. So bore versus circular? That is a fantastic question, and I don't know if I have an answer for you. So in the post-practice assignment, which you guys will go through, you will notice that they lead in and lead out a little bit differently. And that may be part of the key of what it is. I honestly don't know where you'd want to use one versus another. They're almost interchangeable. I can tell you the bore will probably get you better results if you're in a small hole or in a larger circle. But I really don't know. So we'll have to think about it and we'll talk about it next time. Hopefully we'll have Austin here too so he can kind of shed some light on it. Okay, awesome guys. Okay, we're gonna switch over and talk about tools real quick. And then I'll show you the engraved toolpath, which is pretty simple. Okay, one piece of confusing terminology we have in the shop that I know confused me for a while and is confusing for a lot of people is the term chamfer mill versus chamfer tool versus drill mill. So I actually don't have a picture of a chamfer tool up. So a chamfer tool, chamfer mill and chamfer and drill mill. Okay, there we go. So this is a chamfer tool. Chamfer bit, I should say. So a chamfer bit is primarily designed for drilling. So these ones are not used for edge milling at all. You see they have multiple flutes on the front, but their flutes are relatively dull. These tools have some of the highest axial load forces you'll ever see in a tool. Usually we only do them by hand because we've broken so many of them in CNCs, it's not even funny. These are probably the ones you're familiar in your parents' workshop in the garage if you've ever used one. We don't use them very often unless we're on the drill presses. Instead, milling has given us two different options. So there's a chamfer mill, which is actually made for side cutting as well as axial cutting. Chamfer mills are primarily used for side cutting. So if I want to put a chamfer on the outside of some contour, I can come in and I can mill the outside of that, but they're not made for cutting very deep. We actually do not have many of these, if any, that I know of. We've chosen to go for something called a drill mill, and that's not a very good picture. Let's see if that one's better. But what it's hard to see on these ones is it has that same chamfered tip, but it also has the flutes of a regular end mill. So you can actually side mill with a chamfer mill, just like you can with a drill mill, like you can with an end mill. You can also chamfer with the tip. We have several of these floating around, and these are what's loaded in the machines already. Let me see. Maybe a 4 flute will be easier to see. Yeah, not much. Anyway, they have the tip angle. You also get different angles on that tip. So you can have a 90 degree, you can have a 60 degree, or you can have a 120 degree. They all mean different things, but for now we're just going to keep it at geometry and say, just make sure you have the right geometry in your tool path and you know what you're going to use it for. With tools with a tip like that, naturally we get some weird stuff. We'd never want to use something like that for roughing. We'd never want to use it for like plunging in and cutting out slots, unless we want those slots to have a V. So we can actually do something really cool with them called engraving. So I've set up an engraved toolpath here, and I've selected this text that I've put here. This is a little ABC board I made for Scott, in case y'all are wondering. But if it'll generate in the next year or so, I'm gonna kill the bulkhead here. What's your deal, homie? Okay, well, I'll just show you how I did it. So when you select a tool that's a chamfer tool, meaning it has some tip angle, you're allowed to do different operations. We'll talk about chamfering later, but we'll talk about engraving now. When I come in with this guy, I can select lines that are separated by each other by some amount. So text automatically does it, but in this case, I've also made these two lines that are separated by a variable amount, make kind of a squiggly. When I select those ones, it comes in and it should generate. It's just probably gonna take half a decade. Sorry guys, I generated it before, but Fusion has this nasty habit of dirtying your tool paths and then making you regenerate all of them. Pain in the rear. Sorry guys, should have protected these tool paths or something. So in case you guys are wondering, Fusion will sometimes dirty your tool paths if you save and leave. In order to prevent it from doing that, you can right click and say protect toolpath. And what that'll do is it'll say, okay, I may or may not change other geometry here, but if I change geometry, assume that that toolpath stays the same. It's a little dangerous, but if you know you're not going to be making any more changes, it works just fine. Okay, well, maybe while that's generating and taking a decade, I'll show you guys what you'll be doing for your next practice. So I will give you guys, I have it ready this time, which is great. You guys are going to get a weird plate thing that looks like this. That has a couple straight holes and a couple tapered stuff and a couple straight pegs and tapered holes. It's a real mess. It's great. And what you're going to do is you're going to make a setup, and then you guys are going to get some 2D adaptive practice, and you're going to rough out the top of this thing. So basically rough it down to that surface and not worry about the pegs. This is where that face selection is going to bite you in the butt. If you select just the face, your toolpath is going to violate some constraints, and it's going to break your tool. Because if you select that face, you're telling it the material that's above these holes doesn't exist, so it assumes it can mill around it, and it'll actually do some weird stuff and break a tool. You'll go through in here and you'll actually take some time to look at what happens. Then what you're going to do is you're going to do a couple bores and circulars on these different toolpaths. On these different features. You're going to compare them. You're going to use different tools, and you're going to try to think of different situations where you do them. And you're going to play with some of the basic parameters. This one will be really quick. Then you'll come in and you'll get some practice engraving. You'll put some text on a plate. You'll model something that looks like this-ish, and you'll engrave it, and you'll see what happens. You'll need to make a chamfer tool as well. Okay. This one's a lot of playing around. So one of the things about these practice assignments, guys, is if you only have like 10 minutes, that's fantastic. Do what you can in 10 minutes, but definitely do them. I am not the greatest teacher when I'm not in person, and it's really easy to just talk at a screen forever. So you're probably not going to get a ton from me talking at you. But I've spent a lot of time on these assignments going through and really detailing them out into being what you guys can, like exercises you guys can go through and learn from. And this is where you'll get to the point where you can actually check people's toolpaths. You can actually run stuff on the router and really be dangerous in the CNC router world. Okay, well, it looks like we've generated it. So I'm actually gonna hide my model and show you what this looks like. So if you remember those letters, what it's gonna do, the engrave toolpath says, okay, I have 2 lines. I have 2 edges here for you. I want you to go and find the right depth so that both edges of the chamfer mill are engaged on both of those edges. So you'll see in here that it's actually variable depth. So this line on the outside is not all happening at the same depth. The tool goes in and out of the board and actually moves in 3 dimensions in order to make those lines work right. You'll also notice where it does these kind of upticks on the edges. That's to make the edges of letters square. So I'm going to show you guys what this looks like in simulation. I'm going to hide my model so that it doesn't get in the way. But we're going to simulate everything. We're going to show you what it looks like. This is one of the really cool things that CNC routers are used for way more frequently than anything else is sign making. So you see this tool comes in, I'll slow it down so you can actually see what it's doing. If you see, it plunges in and out to get the right width based on a depth. And we'll just watch it go through. So you'll see it come through and it'll do outsides, and then it'll do all these letters. And you'll see these letters have square corners, which is weird because we're using a circular tool. But that tool is dragging itself out and using its tip to make it look like corners are square. This makes lettering that's really, really clean and really, really fast. Yeah, with my router at home and taking router jobs and stuff, this is primarily what people want to pay for, is having really fancy, fun signs. They're also really cheap and easy Christmas presents if you guys want to blow away your relatives. But the engrave toolpath is a really, really useful tool, not just for making fancy lettering, but primarily for making fancy lettering. Okay, well, you guys will get some playtime with that in the practice assignment. Any questions about the engrave toolpath so far? Awesome, guys. Well, take a stab at that practice assignment and really enjoy it. Fusion's really fun. I hope those of you who are continuing to go in the shop can get someone who knows CNC well enough to sit down and actually help you mill some stuff out. The ShopBot is a royal pain in the bum to work with, so I don't recommend you use the ShopBot with Fusion. But I'd recommend trying a little bit of stuff on the mills with aluminum. See if you can get a plate and engrave it if you want to, do small lettering, or see if you can get somebody who knows feeds and speeds in Mastercam at least to sit down next to you, and the feeds and speeds transfer directly over to Fusion. So if you've milled aluminum in Mastercam, you can do aluminum in Fusion. Play with some stuff, figure out what you can do. I'm sure Nick is fine with you guys burning through some scrap aluminum to really get some insight here. Oh, it's Austin. Wow, hi, Austin. Okay. Any questions before we take off?
I have a question, Tyler.
Yeah, fire away.
Do we have G-Wizard or something yet?
Oh, I have not coordinated a ton with Nick on that. That is something I need to do more of. Thank you for doing that. All we've really talked about is that FS Wizard thing.
Okay, that works great.
But yeah, I definitely recommend people start taking a stab at some simple aluminum parts with Fusion and really getting a feel for what it does. Those of you who are at home, sorry, you don't have a machine. Not a lot you can do other than learn to click buttons, but that's okay. When you get back, you'll be really good at button clicking and just need feeds and speeds. Okay, guys, thank you very much, and I will see you all next week. I'll post that practice assignment right now. Oh, Cam, you have a question? Oh, you're saying goodbye. Bye, guys.